Hi everyone, and welcome to our first video lecture recording. We will see how this goes. We're going to go ahead and jump right in. This is the Chapter 9 lecture. It's titled Solutions on Blackboard, so make sure you have the right slides. But per usual, when we start a new chapter, here's a picture of a hike I just wanted to show you guys from a hike we did in Nashville, Tennessee area. It's called Fall Creek Falls. There's tons of waterfalls in this particular region, and there's lots of good bike riding trails. Not as much like avid hiking if you're looking for like an intense trail, but some good leisure hiking and some really pretty waterfalls. So this one is the largest one there that we're looking at, and it's a 256-foot drop. It actually is the largest waterfall east of the Mississippi River, so pretty cool area to go check out and explore if you're in or around Nashville. But moving on, let's jump into Chapter 9. So we're going to talk about solutions. First thing we're going to do is we're going to classify and understand what kind of matter is a solution. So if you remember from the first week of classes when we were just talking about what is matter, we had a chart that looked like this at the end of the lecture. And you guys had to learn and know the difference between some of the terms you see on this chart. So remind yourself that when we first talk about matter up here at the top, we ask this question: are the properties constant or consistent? Does it have a consistent composition? If it does, we know it as a pure substance that can then be a chemical compound or an element. But if it does not, then it's a mixture. Okay, and as you see at the bottom, a solution is a type of mixture. And particularly, we have two types of mixtures. One, we have a heterogeneous mixture. Two, we have a homogeneous mixture. The difference being that in a heterogeneous mixture, you have an uneven distribution of elements or ingredients of matter. Okay, the matter that's in the mixture. Homogeneous mixture is even, the things are evenly mixed. So the example that I like to use, I'll just say evenly mixed. Vanilla, can't spell today. Vanilla ice cream is the example I like to use. Okay, in vanilla ice cream, everything is evenly mixed. There's definitely multiple ingredients there. You have the sugar, the milk, you have air whipped into the ice cream, so everything's evenly mixed. All the bites are the same. That's a homogeneous mixture. Heterogeneous mixture, things are different. You throw some Oreos into that ice cream or some M&Ms, and now you have a heterogeneous mixture. Okay. A solution is really what we want to get to. That is a homogeneous mixture. Okay, so first thing to know here is that a solution is a homogeneous mixture. And now let's look at exactly a more definite, a definition for what a solution is. Here we see a definition that says a solution is a homogeneous mixture of ion or molecule-sized particles. Okay. That's what makes a solution a solution. If we scroll back up, you can see there's also another type of homogeneous mixture known as a colloid, okay? And we'll talk about how these are different right here by looking at this table. So this table is in your textbook. I don't know the exact figure number, but in one of the early, maybe even the first section of Chapter 9, here's how a solution and a colloid are different. It's according to their particle size. So we know that ions and molecules are really small. In fact, anything less than 2 nanometers in diameter, anything with that particle size, we're going to consider that type of mixture as solution. So it gives you some examples here. And another key thing to note, though, are the characteristics. You can generally see through solutions. They're usually clear. And if you were to just let it sit for days and days on a counter, they do not separate. Okay, you can't filter the particles out. A colloid, though, larger particle size, between 2 to 500 nanometers. So it gives you some examples: buttermilk, things like that. Milk, we know, has fats in it. It's got sugars. And those are biological molecules that are definitely bigger than ions, okay? And so colloids, you can't see through milk, right? But you still can't filter out the particles, okay? It does not separate. So that's one way they're similar, but they're also different based on their particle size. Heterogeneous mixtures have the largest type of particles in them, anything bigger than 500 nanometers in diameter. And by the way, let me pause. Anybody remember how big a nanometer is? We know that 1 meter is 10 to the 9th power of nanometers, okay? That's a billion nanometers in 1 meter, okay? So a nanometer is very, very small. We can't see things visibly that are down in nanometer range without a microscope. One interesting thing about heterogeneous mixtures here, blood is a heterogeneous mixture. And you'll notice when you have a heterogeneous mixture, things can separate if you just let it sit. If you had a container of blood in a refrigerated area, if you let it sit, blood has, we'll just draw down here, things that would separate out. Blood has red blood cells and white blood cells, and these things would separate out of the mixture if it just set. Blood also has, the largest portion of blood is known as plasma. And interesting enough, plasma, if we took the red and white blood cells out, what would be left, blood would now be a colloid. Okay, so plasma is down in the size of colloid particles. Blood also has electrolytes. Okay, so if we took the red blood cells, white blood cells out, if we took the plasma out, what would be left is electrolytes, and that kind of solution would classify blood as that kind of mixture would classify blood as a solution. So blood actually has components of all 3 types of particle sizes, but because all 3 are in there, including the cells, we say it's a heterogeneous mixture. All right, moving on. There's 2 portions to a solution, 2 parts. Number 1 is the solvent, okay? This is usually a liquid, not always though. This table is going to kind of expand our thinking when we recognize how many different types of solutions there are, but usually the solvent is a liquid, and that's what we're dissolving our particles in, okay? The particles could be gas or solid, and the thing we're dissolving in our solvent is what we call our solute, okay? That is the dissolved gas or solid. So take a look at this table. It's probably really good to recognize that our atmosphere, okay, that is a type of solution. Gases mix with other gases. You can have a gas and a liquid, obviously a carbonated beverage. My favorite, actually listed here, seltzer water. Carbon dioxide mixed in water is a solution, so on and so forth. The most common thing we think about is a solid dissolved in a liquid. Salt water is a great example of that. If we had the coronavirus in a liquid, coronavirus is, it's a virus, and it's about 120 nanometers in size. So what kind of mixture would the coronavirus be? Actually, it would be a colloid, wouldn't it? Not a solution, okay? Moving on, solubility. So this is, we've now defined what a solution is and the different parts of a solution, and the next thing we need to